Today's patient is an ADAM A5X studio monitor. It's got a pretty gnarly buzz and we're not hearing any audio pass through. We do see power come through and the LED shine, which is good. But this, not so good. Let's pop all the screws off the back and take a look inside. You always got to be careful with these studio monitors because of how tightly they pack in the wires. Got to pop off these 3 connectors on top, and there's 2 connectors a little bit lower for the speakers. Keep the Pokemon hoodie. Who's your starter? I'd go with Squirtle. This last connection soldered into the board, so you have to take off the spade connectors that are actually onto the tweeter. Just so I don't forget, took a shot there, and it looks like blue's on bottom. Best part of these repairs is taking a razor blade to try to cut some of the glue off of these connections. It is both very delicate and very aggravating. This is the kind of thing where you'll lose your cool, slip, and then break something you can't replace. A couple screws along the edges, and then 2 in the heat sink in the middle of the board. I like this design though, because you can just unscrew everything from the heat sink. You don't have to desolder to get the board off. It pops out real smooth. Let's give it a good visual inspection, see if we notice anything funny. You see what our one problem is here that we definitely have? Looks like this cap here is doming. That one's got to be replaced for sure. A little bit of flux, a little bit of desoldering braid, and even a solder sucker to pop this cap out of there easy. Even looked a little domed on bottom. Since this speaker's about 10 years old, I decided to start checking the other capacitors in the circuit, and a lot of them were actually testing poorly. Can't trust in-circuit measures, but they do give you a good idea. Unfortunately, most of them that were testing bad in the circuit also tested bad out of circuit, so I had to recap a whole bunch of this board. I like taking the time to try to understand the root cause and the one problem that I can fix. However, this one probably could have used a shotgun because every capacitor I tested seemed to be going bad. At this point, I'm not sure if the main problem was the original capacitor that was bulged in the power supply, or if one of these was leaking and letting DC onto the speakers. Either way, this speaker is going to be a heck of a lot healthier after this. It's like a spa day for your tech. I didn't particularly count, but I think there was at least 16 bad capacitors in this circuit. I also like to recheck every now and again, just make sure the new parts I'm putting in match specs on the multimeter. I started making these videos because I've gotten so much help from finding other videos for my problems. So do me a favor and subscribe if you find these things useful, and I'll keep making videos. Or leave a comment and tell me what I can improve on so I can help anyone else following. So we had to take a look at the pre-amplifier board because there's more capacitors on there, and I just was starting to not trust anything. Unfortunately, this was a big pain in the butt because I couldn't get the plastic shield off fully. So I started marking the capacitors that I had checked or replaced that tested good, and we ended up with maybe 2 or 3 that actually tested good in circuit. So these mostly needed to be replaced as well. Unfortunately, I had to desolder that XLR connection to be able to get down to 1 capacitor. Only special piece here is I did put a little bit more thermal grease on the op amp. Put all the screws back in, tighten up the heat sinks. And a word of caution as you're starting to put things back together. Make sure you have everything attached and in the right spots first before you decide to tighten everything down. I had to redo this heatsink thing about 3 or 4 times because I kept forgetting small things like that thermal grease. Get the amplifier thrown back in the cabinet. Remember, it's blue on bottom. Let's give her a little test now. What do we got? Good. Still turns on. Got some audio. At least the buzzing's gone, but it sounds like it's underwater. So I'm checking the tweeter here to see if I cover that, if it changes any of the sound, and it seems like we're not getting anything coming through the tweeter. And unfortunately, these tweeters are about $250. Not easy to replace, financially. First step here is to check connections, so I already knew the spade connectors are on right, so let's take the tweeter out and see what's happening. I do not think tweeters run on Bluetooth. That wire has to be connected somewhere. Maybe it got jiggled loose from the bumping music. Maybe in shipping or transit it got broken off. Either way, we got to strip it back and resolder it back in. Tin up that wire, heat up the solder on the pad. Make the job a little bit easier for yourself. At least this looks to be a simple fix and not a blown tweeter. Four screws going back in. 8 screws or so, round the outside, round the outside. And let's give it one more test, and hopefully now it's all working as expected. Here we go. Very nice. That was our problem. That sounds so much better. Raka. Thanks for sticking around. If you had fun, check out a few of my other videos.